Okay, in this video we're going to use Geogebra to construct an angle bisector, and then we're going to look at a conjecture we can make about angle bisectors and review the given facts so that you can then prove that. So again, I started by going to www.geogebra.org. On the home screen I click on Start Geogebra, and then I click on Geometry to get my canvas. So I'm going to first make an angle. Now an angle, you might recall, the definition is that it's two rays with a common endpoint. So in this third button from the left, I'm going to pick ray. When I left click, it gives me one endpoint. When I release the left click, it gives me another point. And if I do that again, if I hover over this, it'll make it the common point. And there, now I've got an angle made up of two rays. Okay, now in order to get the angle bisector, I'm going to go to the 1, 2, 3, 4th button from the left. We'd been using this button to make some perpendicular and parallel lines. I want to go to the 4th line where it says angle bisector. The gray box says select 3 points or 2 lines. It turns out to be better to select 3 points, so that's what I'm going to do. 1, 2, 3. There we go. Okay, so now I've got an angle bisector, and if I use my move button to make this angle a little wider or change its angle a little bit, the angle bisector is still going to be exactly halfway down the middle of that angle. So that's how Geogebra has defined that line. It will always bisect the original angle. Alright, well now what I want to do is put a point on that bisector. So I'm going to go back to the point tool, pick point on object, and hover over the bisector till it gets bold. Stick a point on the bisector. This point cannot move off the bisector. It can slide up and down the bisector. Okay? And then what I want to consider is the distance between this point on the bisector and the two rays, the sides of the angle. Okay? Now, there's a principle which I think will make sense to you if you think about it. In geometry, if we want to measure the distance from a point to a line, we want the shortest possible distance between that point and that line. And so the shortest distance would be going perpendicular to the line. Think about if you wanted to cross a river and you were here, the shortest distance to get to the river would be going directly to it. You wouldn't want to go off at an angle. That would take longer. Okay, so what I'm going to want to do is make a perpendicular to this ray from this point, and it's probably not going to go through this point, so I'm going to hide this point and this point because they're just going to be irrelevant. So this right hand button gives me the option to show hide object. I want to hide that point, that point. If I click on a different tool like my arrow, then they disappear. So they just won't be there cluttering things up. Okay, so you might recall that one of the options for how we make a perpendicular, when we go to our 4th button from the left here, perpendicular line, we select a point and the perpendicular line, and that point, it can be either on or off the line. So I'm going to pick this point and this ray here, and it will construct a perpendicular for me. Okay, so this, I want the shortest distance to get from this point to this line. Here's the perpendicular, here's the path I should take. Okay, I'd like to have a point there. So I'm going to go to my point tool to intersect, and I'm going to hover right where those two intersect, and I get a point. Okay, so this distance from here to here, I can measure that. If I go to the 5th button from the right, I can measure distance or length. I can measure, if I pick these 2 points, it will tell me the distance between them, and it says that this distance, it has even named the points for me now. This distance ED is 5.38 centimeters. Okay, now I want to compare that to the distance from this point D and the other side of the angle. Again, I need to construct a perpendicular so that I know what path would be the shortest path from D to this side of the angle. So I'm going to go back to this fourth tool from the left and pick perpendicular line, pick D, pick this side of the angle. There's my perpendicular. I want to put a point at the intersection. So intersect these two, and I want to measure. So I want the distance from D to here. And that distance turns out to be 5.38 centimeters, just like the other distance. Let's look at what happens if I move this point D somewhere else, so I need to pick up my arrow tool in order to move. I want to go to a different point on the angle bisector. So I'm still on the angle bisector. Okay. Now ED is 7.41, but DF, this distance here, is also 7.41. And if I get closer to the vertex, this distance is 2.41, and this distance is also 2.41. So here is a conjecture about angle bisectors. We can pull up a text box and give ourselves a conjecture. We'll say a point on the angle bisector is equidistant from the, the sides of the angle. And remember to measure the distance from a point to a line along a perpendicular. Just remind us that that's how we measure that distance from the point on the angle bisector to each side of the angle that we have to measure along a perpendicular. Okay, so that is my conjecture. I'm going to make it bold, and I'm going to move it up here so it's off my picture. Okay, so let's think about what we know. We know that this is an angle bisector. That means that it has split the angle into two equal parts. These two smaller angles right here are equal. That's the definition of an angle bisector. Okay, we also know something special about this angle here. It's a perpendicular pair of segments, so we know it's 90 degrees. And similarly here, this is also 90 degrees because these are perpendicular segments. So with that given information, see if you can write down anything else that you know and prove that this conjecture is going to, in fact, be true all the time, that it's actually a theorem.